Great. So I'm going to record this now, but this is where we're going with computing, and you have to understand that there's a huge amount of it's like standing on a mountain in terms of the actual computing that's going on before we get to that data science and artificial intelligence, this type of thing that sort of behave like a human, get some computer to sort of do that is, well, that's a little bit different also, because data science, artificial intelligence, a lot of that is just about sort of coordinating different bits of data and making and determining correlations that nobody else could see. But you know, in a way, our mind does that as well. But I'm sorry, I'm going on a little bit of segue here, but the point that I'm trying to make is that we've done a lot of computing in the last sort of 80 years since people first started using vacuum tubes to do some kind of calculations, which were very basic. I think the first actual computer application that was the first famous one that I know of was the breaking of the Enigma code done by, I think it was Turing, a British scientist in the UK, of course. And so he had a machine which had a lot of mechanical parts to it, actually, and sort of just had spinning discs with numbers 0 through 10 on it. And, you know, lots of these. And by doing multiple calculations is able to look at code that was being produced by their enemies in the war and be able to break that code. That was so that was one of the first applications. Yes, I'll mark you all present in a minute. So I'm sorry that if our first lesson is just sort of introduction anyways, but the point that I want to make is there's a lot of computing that's gone on before what we do and try and do with computers at the moment. So, I mean, we're using a computer application at the moment. You can see me and I can see you. And well, those of you that choose to show me, I can see you. But that is actually all happening with computer program. I mean, and you might look at it, oh yeah, I use computers, you know, I press a couple buttons here. But there's a lot of computing underneath that. So you got an operating system that is managing all of the different components of the hardware computer. And then you have our applications which instruct the operating system what it should be doing next. And these applications are really quite complicated. Now, what we're going to be doing in this course is sort of to strip away all those layers and just think, what if we were just going to solve a problem as if we were the most basic computer? I guess you could think as if we were kind of like a hand calculator or something like that. If we are going to solve the most simple problems, to try and do it as a computer. And that's basically using very simple logic, which is true, false. You know, if it's true, it can't be false. If it's false, it can't be true. This type of thing. So we've got that very simple logic that we use, and then we have numbers and mathematics. Mathematics translates to computers perhaps more easily. I won't say directly, because actually the way computers work is with zeros and ones are the actual basic sort of code, which is instructing the hardware what to do. Zeros and ones, we call that binary numbers and binary language. So that is how the computer itself is instructed. We have to turn everything into those zeros and ones, which we can. So there's, as I said, there's been a lot of really smart people over the last 80 years have been able to take the rest of the world and sort of configure it in a way that a computer can deal with it. And the idea of this course is to get you to sort of start thinking in that way. How would we arrange things? And to do that, we need to make things, we need to take problems which seem to be a standard problem and make it as simple and as it possibly could be, so that it can be solved in a number of repeatable but simple steps. Now, I'm going to emphasize the repeatable bit there a little bit, because that is the strength of computers. I mean, if you've got a one-time problem which has never been looked at before, probably you're going to find some people that are going to be the ones that are going to look at that. But if you have a problem which is pretty standardized and people have been doing this problem a lot, and we're going to do it a lot more in the future, that is ideal for creating an application. Now, I mentioned that we are approaching the point where computers are getting something like human intelligence, and not as good as, nowhere near. So about 5 years ago, we had a lot of sort of buzz about the idea we're going to have automated or autonomous vehicles on our roads everywhere. Tesla Motor Company has a sort of autonomous unit that's added to their cars. People were talking about automated trucks, and so there's going to be no need for drivers anywhere. Uber was going to produce something, Google was going to produce something, and they actually had an incident. This is about 4 years ago, where I think it was a Google car was being in testing, and they're very happy about this car. It's doing all these things, no driver, and it's just going down the road. And what happened is a cyclist came into the path of the vehicle, and the vehicle knocked down the cyclist and seriously injured that person. May have killed them. Now, that of course set it back, right? Now, that doesn't mean that the car is less safe than a human driver, because lots of humans knock down cyclists. But shouldn't happen, right? I mean, if we have a computer, it should be able to determine a cyclist. And that's the problem there was in the sensors, right? I mean, it's and the processing of the images. That is, human brain, it's not just easy to sort of do what the human brain is doing when it sees things. And we don't even understand everything about what we see. And I guess that what was the problem with that particular instance, is that there's some missing component to that action of sort of seeing things moving in a road situation. They haven't got their finger on yet for the automated cars. They will, I imagine, but it's not today. So don't worry, if you want to be an Uber driver, there's still a job for you for the next couple of years anyways. So that's sort of little introduction, I suppose. I want to have us to start with a little practical exercise, which is critical thinking skills. But before I do that, as maybe there's some things that you guys would like to sort of, maybe something that I said in my sort of little introduction there prompted something that you'd like to respond to, or maybe there's some question that you have or anything else. So let's just stop for a second now and see how students are going. Is there anything that you'd like to add? Now, by the way, I will say to you that I may not be able to go beyond 40 minutes in this, is what I have with the way my Zoom is set up, is that it'll stop after 40 minutes. If you want to continue going, I'll try and open it again after that, but you should expect that this is going to be about 40 minutes. Okay, any questions? No. Any points? You can put stuff in the chat. All right, so I assume you guys are still there, right? Still awake? Still there?
Yes, we are here, sir. Did you talk about Alan Turing?
About who? I did talk about Turing when I was talking about the breaking of the Enigma code. I don't know if I
Alan Turing, the World War II scientist that cracked the code for warfare, I think.
Yeah, he broke the code for what they called the Enigma. And that was important because that was used by the German Navy to communicate between their boats, which were sinking all of the boats coming across from Canada and the United States to Australia, to UK. And they're able to break that code, and therefore they're able to sort of know what's going on and not have so many boats sunk. We are going to, so I do have a question here from John Rubin, and it's, are we going to have face-to-face classes next week? All right, so this is a problem because of the size of this class. So I am going to have to take that on advisement because I don't think I've got a room where I can put 24 people in it at once. What I could do is I could go to the classroom and people who show not make it mandatory. I think if I don't make it mandatory to come, then some people won't come. And so what I could do is I could do what do you think of that, folks? Is there anybody here that thinks if I didn't make it mandatory that they would stay at home? Because if I do that, I mean, as long as I have not more than like 15 people in the classroom, but if I think I'm going to have like 24, I might have a problem because of Corona. I hate this Corona nonsense, right? So I got a few people who like to come. So, okay, you know what? I'll try it. If you like, I'll try it in the next lesson. I'll send out an invitation to you to come and join it as online, but I'll also go down to the classroom so you can come there. And yeah, I like in-person classes too. So I think we can try it. But as I said, if I end up with 24 people down there, then I'm not sure what I'm going to do. I'll talk to Greg, talk to our managers about it and see if that's going to work. It's possible. Not certain, but it's possible. As I said, just because of the corona. So like at the moment, we got 17 people. If you guys were all the ones that showed up at that classroom, it'd probably be better. Yeah. So, you know what I mean?
There is new decision coming maybe today or Sunday regarding phase 4.
Regarding who?
Regarding phase 4 of COVID-19
So
ban
you're
lifting.
going to have a announcement from the government. Yeah. So, I mean,
Yes.
what I have to come to work every day. I mean, the last thing that I saw was, 100% of all faculty need to be at college, unless we have an excuse. I don't have any excuse. I'm healthy as I've ever been. The other thing is that, but only 50% of students. So we can only have 50%. So, and the other thing was that we could only never have more than 15 in a class. So I won't say that it's online. I'll put something on D2L. I think you can come to the college. You can all come to the college anytime you want. Nobody's going to stop you from coming to the college. And what I can do is I can go down to the classroom, and as long as I don't have more than sort of 15 people show up there, we could have a class there, and I could also put on my video and record it, and so I think we could do both. You know what I mean? I'm hoping that we could have that flexibility within the class, but that would mean that if you feel like you want to stay home, then stay home, and do it online. It's okay. Definitely I'm not going to be sort of demanding that people come to classes, not at the moment. But I will go down to the classroom. And so how's that sound? As a sort of a halfway measure, I'll go down to the classroom and I'll do the class from there next week. Some people show up, as long as it's not more than 15. We'll have a class there. And so we'll have a mixed mode, half online, half in person. Sounds good? I hope. What I like to do with you is I like to share my screen with you, and let's look at a little exercise. Now this is not a I should be careful how I say about those things. This is to get you thinking, right? This is not sort of part of the straight up course. It's just to get you thinking. So let's get you thinking. All right. So I've got this exercise, and it's called critical thinking. And yeah, critical thinking is lots of things. It has to do with how do we determine if information is true or false or fake news, that type of thing. That's critical thinking. And academics, scientists, they're supposed to be really good at this critical thinking. And so in universities, we demand that before we take anything seriously, what we do is our articles must be peer reviewed, and they must be published in a reputable journal. And from that point, then that's our launching point to look at things that are we can take as being real. So we don't sort of go to Facebook to get our information. We go to peer-reviewed articles. In other words, we look for something which is in the consensus of the current sort of scientific thinking, using a scientific approach. Now, that's one way of looking at it. But then if we get down to the more sort of nuts and bolts at an individual problem, I've got an individual problem. I'm not seeking to get lots of information from my peers. What I want to do is I just want to solve this problem. Then we start looking at logic, which is also applied in that other sphere. We start looking at logic, and we start looking at sort of stepwise refinement of large problems into small problems, applying logic to them, applying ways of thinking that we know have worked in the past, and looking for patterns and seeing if those patterns are repeatable over time. So that's the kind of critical thinking that we're talking about here. We're going to be looking at, and maybe I can, I don't know if you can see this. I hope you can see this. Maybe I can, yeah. Can I make that bigger? I don't know. Is that big enough to see? I hope it is. but maybe you can see this first activity. Yeah, I can make it bigger. Oh, then it, yeah, rotten thing. Then I run out of room on the sideways. Anyway, so what I hope you see here is a pattern going forward. This is common in tests where you have tests where you might be given a test like this if you go for a job and they're trying to figure out, can you do this kind of thinking? And so they'll give you a bunch of shapes and stuff and say, what's the next shape in the sequence? And so that's what this one is. Pretty simple one. What's the next shape in the sequence? Who can tell me what's the next shape in the sequence? Number 4. So 1 is like that, an L with 1 in the corner and then 1 on each side. The next one, 2, has got 1 in the corner and then 2 on each side. Next one, 3, has got 1 in the corner and then 3 on each side. So the next one, 4, is going to have, hello? Anybody want to say anything? I don't have my chat up. I've got it hidden there. We will put 1 square right and 1 up, same 5. Yeah. So each time you do this, you add 1 square up and 1 square to the side. Yeah, that would be a pattern. And a computer could do that repeating and keep on doing that over and over again. So somebody said something, it was a lady's voice. Can you say it again? Sorry, I interrupted you. Now going shy because I interrupted you.
Yeah, a 5th block is added in the 4th column.
The 5th block, the 5th block, sorry?
A 5th block is added in the 4th column, I guess.
Yes, so on the 4th, so I think you're saying, well, look, this is 4 high and 4 wide.
Yeah.
With the 3. So with the 4, it's going to be 5 high and 5 wide.
Yes.
And with the 5, it's going to be
the 6th one.
6. And with the 10, it's going to be 11 and 11. So you could now you could make that into a formula, because the thing that it wants to know is how many squares in each of these patterns. So if you looked at this one, the number is 1, or n is 1 because it talks about the nth. N is 1, and the number of squares is 3. N in the next one here, n is 2, and the number of squares is 5. Then the next one, n is 3, and the number of squares is, so I mean, you see me counting up the squares, right? There's 4 that way, and you can't count this one twice. So 3 that way, so that's 7. So we could maybe make a formula that would take n, convert n into the number of squares. So the number of squares is equal something n. So in this case, if n is 1, it's going to be, you could say n plus 2. Maybe there's some other ways of doing it. Well, maybe if we look at this one. So if n is 2, then it's not n plus 2. So it's got to be something else. And actually, well, what would happen if we took n and multiplied it by 2? So that would give us 1 for each side. If n multiplied by 2 and then add 1 for the corner. So maybe n is how we build out the sides and the top, but there's 2 sides and top if you add them. So 2n, that gives us those four blocks plus 1. And that works here too, right? 3n plus 1. So sorry, n is n. Sorry, I don't want to confuse you. It's 2n, and in this case, yeah, 2n, where n is 3. 2 times 3 is 6, and 1 is 7. So for 4, the total number of blocks should be 5 up, 5 to the side, but only 4 because we're moving over, right? So that would be 2 times 4, which is 8 plus 1, which would be 9. So it should be 9 there. I think you can see that this would be 11. This would be 21, etc. Do you get it? So looking at that pattern, we can break it down, in this case, I think, to a mathematical formula. I agree with, okay, so who's that? Is that Muhammad? I got a message from Muhammad who says it's 2n plus 1. That is the formula that I would use, yes. 2n plus 1. That's what I think. So there you go, 2n plus 1. That's just math. but it represents a pattern. And if you were paying attention at math in high school, you probably would have noticed that they spent a lot of time doing patterns. And then you saw that those patterns could be represented with some kind of mathematical formula. And that's good because math is like, it's like even simpler than the simplest sort of languages, isn't it? I mean, look at that. We got like 5 things there that explain exactly what's going on in that pattern. It's very nice. It's what we call abstracting, taking something which is complex and breaking it down to something kind of simple. And that's about as simple as you can get for that, I think. You guys okay with that? That's what I would say there. Correct, Mohammed. I would say that that is 2n, where, you know, 2 to represent 2 sides, n to represent the number in the sequence, and then plus 1 for the corner. All right, let's look at the peanut problem. Peanut problem is kind of fun. We're just going to do a couple of these, and I'm going to leave the rest of them for you to do as your homework. Now, let me look at our time because we are going to run out. And it is just an introductory course, introductory lesson just to get you thinking. But can you think of this one? Have a look at this one. Twice as many Brazil nuts as cashews, twice as many peanuts as Brazil, same number of almonds as Brazil. And the total is 81 nuts. So can you convert that into some kind of mathematics and then solve it? I'll give you a hint here. What you want to do is you want to break them, is you want to sort of equate them all to one thing. So let's look at it again. If you know how many cashews you have, then the total number of Brazil nuts would be twice as many. And if you knew how many Brazil nuts you have, then the total number of peanuts would be twice as many as the Brazil nuts. And if you knew how many Brazil nuts you have, then the total number of almonds would be the same as the Brazil nuts. So everything sort of relates to everything else. And then it all adds up to 81. Anybody got some ideas on that one? I would work with I would start with the cashew nuts, you know? So I'd say, I'd use symbols like the cashew nuts is C, right? And it all totals, and I'm sorry that this is going to be backwards, but I'm getting my formula there. It's right there. I'm saying, okay, so cashew nuts plus, we're going to add a whole lot of stuff to the C, and it's all going to add up to 81. Now, what I know for the Brazil nuts is 2C. And what I know for the peanuts is going to be 2 times B, so that's going to be 4C. And then the almonds are going to be the same as the Brazil nuts. So you can make it mathematical. And again, I say this, sorry if it's backwards, but the total number is going to be the number of cashews plus 2 times the number of cashews plus 4 times the number of cashews plus 2 times the number of cashews. So, and that all is going to be 81. Well, you could just, now that they're all based on C, we could just add those up to 4 and 4, and you end up with 9C is equal to 81. And then you just do your very basic algebra, divide both sides by 9, and you end up with C is equal to 9. So in other words, there's 9 cashews. Now that I know that C is equal to 9, I can say, well, B is equal to 2C. So B is going to be equal to 18. Peanuts is going to be equal to 36. And almonds is going to be equal to 18. And those all add up to 81. So, I mean, it's math, but it's kind of logical math. I hope that sort of made some sense to you. We're kind of running out of time. So I'm going to leave you with the rest of the exercises for you to sort of ponder in your time at home for the weekend. What I will say about the fun with logic thing, Ahmed, Badr, Mariam, Fatma spelled with a PH, the way that we like to write Greek words. Sami. Use the logic that you want to use here is the logic of mutual exclusivity, or that is that something can't be more than one thing at a time within this group. So Ahmed can't be Badr, Badr can't be Miriam, etc. And you can only have one favorite class. So if your favorite class is biology, then no other class can be your favorite class, that kind of thing, right? And so by a process of elimination, you can solve this. You can say, okay, so what I would do is I would write down the names of all the people, Ahmed, Badr, Fatma, Miriam, Sami on one side. And then I'd have a pool of all the subjects, and I would just take the subjects out of that pool and add them where they can work. And so I'd start with, is there any one there that is actually certain that that is their favorite subject, given by the clues? Now, these are just clues, and they're not definitive. That is, they're clues. They're not saying exactly this is true, but they're like hints. So you have to be a bit of a detective here. But I think there's a pretty good hint there in the fourth statement about Mariam. Mariam is a very talented athlete. And one of the subjects there is physical education. So that's just to get you started. I think I'm pretty sure that somebody is a talented athlete. You don't usually be a talented athlete unless you like doing it. Just saying. And so it's that kind of thing. Likewise, I'd say that Sami says he can't draw a straight line. He probably doesn't like math that much. You know what I'm saying? And you can't draw a straight line, probably doesn't like art that much. So, you know, for Sami, I would exclude art, and I would exclude math, and I would also exclude PE, because I'm giving PE to Mariam. So Sami, out of the 1, 2, 3, 4, 5 subjects, Sami could only like, it wouldn't be art, it wouldn't be math, it wouldn't be PE. So Sami's favorite subject is either biology or social studies. Now, what I see is that Fatma and Sami both don't like experiments in science. You know, biology is a science. So probably Sami doesn't like biology all that much. So I'm going to say that Sami's favorite subject is social studies. See what I mean? That's the way it works, sort of just by elimination and logic. I've kind of almost solved that for you. I've given you Sami and Miriam, and you can go ahead and sort of work out the rest. Yes. All right. So that's what I want you to do, is go ahead, just have a bit of fun with these exercises. See if you can figure out the favorite subjects of the rest of those students. Then we got a thing with marbles. The marbles exercise, really do try this one. I recommend it because, I mean, so when I look at it, immediately I've got the answer. That's because I studied computing. I mean, you look at it, maybe immediately you won't get the answer because you haven't studied computing. But we actually have a thing. If you want to know the answer to marbles and it doesn't come to you immediately, you want to Google how to get the answer, I'll tell you, there's a thing called a binary, not binary sort, it's binary search. So have a look for that. If you want to, if it doesn't come to you automatically, it might. You know, you might look at it and then, oh yeah, I know this. I can do this. And then in that case, you're already thinking like a computer person. Or if you've actually ever done any computing, you might have come across a binary search. But if not, binary search is the way that works. And the number tricks, again, that's sort of logic. If it can't be this, it can't be that. So I'm going to leave you with this. Now, when I say I'm going to leave you with this, please don't feel that this is not an exercise that it has to be individual. You may talk to your friends, and you may come up with an answer that way. That's fine. If you want to get together and work together on it, that's fine too. Now, in the last couple of minutes about that, what about working together? Maybe we could all work together. So what I'm going to do is I'm going to put my phone number up here, and that's not that I'm expecting a lot of phone calls, because I don't. But what I do is I like maybe one student in the class here, if you'd like to make a WhatsApp group, and then you can add other students to the group, and that would be good, because then we can sort of talk about it, or we could have a few. There's my number. If you do decide, and it's up to you, if you don't like to have a WhatsApp, it's up to you. But I'm just offering that to you. If want to make a WhatsApp group, you can join me to the group. There's my number. And you can send me questions and I will try and answer them outside of class time. And so that's the purpose of that, so that I can sort of help students. You feel like you've got some kind of a communication line that's open to you. So if you like to do that. Nafeel has done binary search in high school. That doesn't surprise me. That's great. So the marbles one, go to Nafeel. He's going to give you the answer on that. So if you like to do this, anybody likes to do WhatsApp? If you do, there, as I said, there's my number, and you could add your own to it. And I won't do the WhatsApp. As I said, so there you go. Rowan likes to do it. So if you like to send your numbers to Rowan, that's going to happen. I like it. It works out pretty good. Okay. So I'm going to leave it at that. I'm going to leave this open for a bit so you guys can send your numbers to Rowan. And maybe there's some other questions that you might have for me. I think I actually already got a WhatsApp sort of adding thing. Yeah. So 14, yeah, you've been added. So thank you. And hopefully we'll get a whole lot more. So I'm on that WhatsApp group, and anybody who I see all the numbers going up there for Rowan to add, that's great. I won't be putting much on there unless I might go there if there's something coming up with an exam, I'll put it on there. But the main idea of that is if you have any questions among yourselves, but also that you want to address me, I'll put it there, and that way everybody can sort of read it, and I think that would be sort of efficient. Any questions? I said I'm going to stop there.